In a quiet New Mexico restaurant in 1950, the physicist Enrico Fermi looked up from his lunch and asked a question so simple, so devastating, that the silence of the universe has been ringing with it ever since. If the galaxy is so old, and the stars so many, and the conditions for life so apparently common, where is everybody? For 75 years, that question, the Fermi paradox, has produced more answers than astronomers can count. The dark forest, the great filter, the zoo hypothesis, the simulation. In 2021, a team of researchers led by economist Robin Hanson at George Mason University proposed something different, something colder, more mathematical, and in many ways more unsettling than anything that came before. They called it the Grabby aliens model. To understand Grabby aliens, you have to start with the silence. Our galaxy contains somewhere between 100 and 400 billion stars. The observable universe contains roughly 2 trillion galaxies. The Drake equation, formulated in 1961 by astronomer Frank Drake at the Green Bank Observatory, attempted to estimate the number of communicating civilizations in the Milky Way. Even with the most pessimistic assumptions, the number it produces is greater than 0, often much greater. And yet, since SETI began listening in earnest in 1960 with Frank Drake's project OSMA at Green Bank, we have detected nothing. No transmissions, no structured signals, no clear evidence of artificial intelligence beyond Earth. The WOW signal of 1977 remains unexplained but unrepeated. The Breakthrough Listen initiative, scanning 1 million nearby stars since 2015, has found exactly 0 confirmed alien transmissions. This is the Great Silence, and every Fermi paradox solution is, in essence, an attempt to explain it. The Grabby aliens model, formally titled If Loud Aliens Explain Human Earliness, Quiet Aliens Are Also Rare, published by Hanson, Daniel Martin, Calvin McCarter, and Jonas Paulson, asks a different question entirely. Instead of asking why we don't see aliens, it asks, where are we in cosmic time, and what does that tell us about civilizations we cannot see? The model imagines 2 kinds of advanced civilizations: quiet ones, which stay near their home star and produce no detectable footprint across the galaxy, and Grabby ones, civilizations that, once they reach a certain technological threshold, begin expanding outward at near-relativistic speeds, transforming every star system they reach into something visibly artificial. The crucial insight is this: if Grabby civilizations exist anywhere in the observable universe, their expansion would be visible. Their transformed regions would show distinct infrared signatures, mass redistributions, suppressed star formation rates. We would see somewhere in the sky a vast region where the natural distribution of light has been replaced by something engineered. We do not see this anywhere. Here is where Hanson's argument turns from astronomy into something stranger. If Grabby civilizations exist with any reasonable frequency, then most observers, meaning most thinking beings, should find themselves either inside a Grabby civilization or surrounded by them. The mathematics is unforgiving. If Grabby aliens are common, the volume of the universe they have transformed grows enormously over cosmic time. Civilizations that arose late should look up and see a sky already partly engineered. We arose at 13.8 billion years after the Big Bang. The universe will continue to be habitable for trillions of years. Statistically, we are extraordinarily early. So early, in fact, that the Grabby aliens model uses our earliness as data, a measurement of when, on average, civilizations arrive. From this single observation, the model produces predictions. Specifically, it estimates that Grabby civilizations arise once every few billion years per galaxy, and that the nearest one is currently expanding somewhere between several 100 million and a few billion light-years away. We cannot see them yet. The light from their transformed regions has not reached us. But if the model is correct, in roughly 1 billion years, our descendants, if any exist, will look up and see the first signs. A patch of sky where the stars have changed. The Grabby aliens model is elegant. It is also speculative, and its critics are sharp. The astronomer Jason Wright at Penn State has pointed out that the model assumes near-relativistic expansion as the natural endpoint of intelligence, a leap most evolutionary biologists would resist making. The cosmologist Sean Carroll has noted that the anthropic reasoning, while internally consistent, depends on assumptions about the reference class of observers that are themselves contested. The model also does not directly answer the original Fermi question. Where is everybody? It only tells us that the loud ones, if they exist, are still over the horizon. The quiet ones, the ones near us, are either rare, transient, or genuinely silent. None of those options are comforting. What the Grabby aliens model does more than anything is reframe the silence as data. Every year that passes without a confirmed signal narrows the parameter space of possible alien civilizations. Each null result from breakthrough listen, each tabby's star explained by ordinary dust, each anomalous candidate dismissed. These are not failures. They are measurements. The Fermi paradox does not have a solution we can verify yet. It may never. But the Grabby aliens model is doing something quietly revolutionary. It is taking the silence seriously as evidence, not as a problem to explain away, but as a cosmic measurement we are slowly learning to read. We are alone in our corner of the sky, at least for now. We are early in a universe that will be habitable for vastly longer than it has been so far. And whatever else is out there, whether close and quiet or distant and grabby, the question of where everybody is may turn out to depend less on alien civilizations and more on what cosmic time we happen to be standing in. If this kind of careful, evidence-based exploration of the deepest questions in science speaks to you, subscribe to Cosmic Edge. We never sensationalize. We follow the silence to where it gets interesting.